Okay, hello everyone. Welcome to Math Kangaroo 3rd 6th grade lesson 4. So today we will be talking about patterns. We will be talking about arithmetic sequences, multiplying patterns, complex patterns, and sums of arithmetic sequences. First, let's talk about arithmetic sequences. Every time we add or subtract a number, for example, in the first case, every time we add 5, so it goes 0, 5, 10, 15, 20, and so on. Next number is 25, because you simply add 5 to 20. You might also subtract a number every time. For example, looking at this, 36, 32, 28, 24, and then 20. You can also figure out the beginning of a arithmetic sequence using the numbers that are already given. For example, in this sequence, the other numbers are 3, 5, 7, 9, and 11. So it is clear that every time we add 2, therefore the first number is 1, because 1 plus 2 equals 3. In this case, we know that the number is 20, because you subtract 4 every time we move forward. In the last example, we can see that we add 3 every time we move forward. So the first number is 22. We can also have multiplying patterns, also called geometric sequences. Multiplying pattern multiplies each number by something to get the next number. For example, in the first case, we multiply by 2 every time. So we know that the last number covered by the question mark, 16, because 8 times 2 equals 16. And in the second case, we can see that every time we multiply by 3. So the first number is 3 because 3 times 3 equals 9. Now let's talk about complex patterns. Wait. Complex pattern is a pattern that requires more than one operation. For example, 9, 10, 8, 9, 7, dot, dot, dot. Looking at this pattern, we see that every time we add 1 and then subtract 2 the next time. So 9 plus 1 equals 10, 10 minus 2 equals 8, 8 plus 1 equals 9, and so on. Therefore, the next number is 8. In this case, you can see that our operations are plus 5 and minus 2, because that is how the pattern goes. 1 plus 5 equals 6, 6 minus 2 equals 4, 4 plus 5 equals 9, and so on. In our third case, you can see that first we add 4, then we subtract 5, then so on. It's plus 4 minus 5. And in the last case, we multiply by 2 and subtract 1 every time. This is kind of special, so 4 times 2 equals 8, subtracting 1 equals 7, 7 times 2 equals 14, when you subtract 1 it equals 13, and so on. Now let's practice. Can you please tell me the next number in the first pattern? If you have the answer, please type it into the chat. Good job. The operation is -3, so the next number is a 3. 6 minus 3 equals 3. Now try it for the second pattern. Can you please tell me the next number or the pattern? Good job. First you subtract 4, then you add 5. So the next number is also 3, because you have just added 5, so you have to subtract 4. Now can you try it for the third pattern? That's not exactly correct because notice that between 12 and 14 you don't add 5. It should actually be plus 5 and then plus 2 because that's, yeah, because 12 plus 2 equals 14 and you repeat the plus 5. So next number should be a 26. So can you please tell me the pattern, the fourth one, and if you can, the next number? Good job. It's plus 1, then 3. So the next number should be 8 because you have just added 3, so you have to add 1. So can you practice with this the this pattern, please? Good job. You subtract 5. However, that isn't exactly the pattern because if you look at 79 and 80, you add 1. So the correct pattern is actually minus 5 and plus 1. So the answer should be 84. Notice that patterns have to work every time. So even if there's only one case where it doesn't work, that's still not the pattern. And can you tell me what this pattern for the second to last one is, please? Good job. It's minus 9 and plus 6. Therefore, the first number should be 86 because you have to add 6 to get 92. Finally, can you tell me the last one? This one might be a little hard, but if we look at the numbers, the pattern is multiply by 2 and then add 2. Because 2 times 2 equals 4, 4 plus 2 equals 6, 6 times 2 equals 12, and so on. And the next number is 30, because we just multiply by 2 to get 28. So now let's talk about the sum of arithmetic sequences. So to do this, let's try to add 1 plus 3 plus 5 plus 7 all the way to 23. Note that we add 2 every time. One way to do this is just do it, but it might take a while, and there's a faster way to do it. So first we add the first and last numbers, then add the second and second to last numbers. Do you notice something? So let's add 1 plus 23 and 3 plus 21. And it's the same thing. So therefore we can make pairs. So 1 and 23, 3 and 21, 5 and 19, 7 and 17, so on. All of these add to 24. So our result is that the sum of the first and last number divided by 2 is the average of this average sum is the average of the numbers. So then when you multiply by the total number of numbers, you get the answer. So in this case, 1 plus 23 equals 24. Then you multiply by the number of numbers, which is 12. Then you divide by 2. And our answer is 144. This is a lot easier than adding it all up because all we need to do are a few simple operations instead of adding 12 numbers together. Now you try. Can you practice the theorem with these 3 arithmetic sequences? Can you please tell me the sum of the first one? So do you need any help or uh, need help, you can ask.
So basically I have to add all the numbers up to 99.
Yes, but there's a trick to doing it. So showed in this slide. So since it's an arithmetic sequence, we can first add the first and last numbers and then multiply by the total amount of numbers and divide by 2. This is because we can pair up numbers, and each pair sums the same thing. So all of these pairs all sum to 24. So therefore, we can use the theorem. By using on 1 through 99, we do 1 plus 99 equals 100. Total amount of numbers is 50. So we do 100 times 50 divided by 2, which equals 2,500. Here's our answer. This is a lot easier than actually adding them all up because for one, it's faster, and number two, it's less easy to make a mistake during the calculations. So, want to try on the next problem, like this theorem.
Where do you exactly get the number that you like divide it by? Or multiply?
So you divide by 2 every time. So divide by 2. So these are what you multiply, and this is what you divide by. So do you need some help, or are you fine?
I think I'm fine.
Okay. So 100,500. That actually is the correct answer. So the way to do it is that the total sum of the numbers is sum of the first and last numbers, 1005. You have to divide by 2, and the total number of numbers is 1000 divided by 5 equals 200. So we have 100,500. Now, can you please try the last problem? 200 plus 190 all the way down to 10. Actually, the answer is 2,100. You got pretty close though. So firstly, we have to add up 210. So we have 210. And we know we have to divide by 2. Now we have to find out the number of numbers there are. So notice that it's simply we have to simply divide by 10. Because we can flip this around and go backwards. So it goes 10, 30, 30, and so on. Since these are all just the multiples of 10, you simply divide by 10 to get the number of numbers. So we have 210 times 20 divided by 2 equals 2,100. So now let's do problems. Matthew builds towers up from little 1 centimeter by 1 centimeter by 2 centimeter building blocks. As can be seen in the picture. He continues to build his towers in the same way. Finally, he uses 28 building blocks for one tower. What is the height of this tower? So I'll give you up to 3 minutes to think about this, and if you have the answer, please type in the chat. So it's been 3 minutes, so since you still don't have an answer, I'll explain. First tower has 3 blocks. Second tower has 6 blocks. Third tower has 10 blocks. And the fourth tower has 1, 2, 3, 4, 5, 6, 10, 15 blocks. You can see our pattern here. Weird pattern, but we add 3, we add 4, we add 5, and so on. So we can add 6 next time to get 21. Then add 7 to get 28. So the first tower has a height of 2. Second tower has a height of 3. Wait, no. First tower has a height of 3. Second tower has a height of 5. Third tower has a height of 6. And so on. Notice that we add 2, then add 1. So
How do you
it's,
find out its height?
wait, what?
How do you find out its height?
So the pattern over here. So is that what you're asking about?
No, I was
So the way we find that is by the height, right?
yes.
So we know that the towers are 1 centimeter by 1 centimeter by 2 centimeter. So if we look at this tower, there's 1 2 centimeter, 1 1 centimeter. So the sum of that is 3. Look at this tower, there are 2 2 centimeters and 1 1 centimeter. So the sum is 5. In this tower, there's 2 1 centimeters and 2 2 centimeters. So the sum is 6. And at this point, we can figure out the pattern. We don't need to count anymore. So it's plus 2, then plus 1. Because looking at over here, we add 2 to the sum and get 8. Because there's 3 1s, 3 2s, and 2 1s. So we know that's 8. And therefore, we can confirm our pattern. After that, we just need to follow the pattern until we find the height of this last one. So then it's 9 and 11. So the answer should be C. Do you have any questions about this one? Or
No.
that's next problem. Emily wants to write a number into every free small triangle. Some of the numbers in the two triangles with a common side should always be the same. Two numbers are already given. How big is the sum of all numbers in the figure? So I'll give you up to 3 minutes to think about this. If you think you have the answer, please type it in the chat. Oh, we have an answer of C. That is the correct answer. The way we get this is that we notice that the only numbers possible in here are 2 and 3. Because if any other numbers happen, then we break our pattern. We simply add the numbers in. So, wait, hold on. 3, 2, 2, 3, 2, and 2, 2. So the sum of these is 21. Next, a big spot of ink covers most of a calendar page for a certain month. What day of the week does the 25th day of the month fall on? I'll give you up to 3 minutes on this one, and if you think you have the answer, please type it in the chat.
Um, what does like it says like mo d me? What does that mean?
Assume it's like kind of weird, kind of assume it's just like Monday. That's Tuesday. That's Wednesday. That's Thursday. That's Friday. That's Saturday. And that's Sunday. So just assume it's like that, even though names are a bit weird. And since agreements have passed, I'll reveal the answers. D.
Is it D?
Yeah. Well, anyways, so when you notice that we reach the same day after 7 days, so we can subtract 7 over and over. Uh, but we have 4, then we can see that 4 falls on this day. So our answer is D. Next, Clara forms one big triangle made up of identical little triangles. She has already put some triangles together, as in this diagram. What is the minimum number of little triangles she has to add to create the one big triangle? I'll give you up to 3 minutes to think about this, and have the answer, please type in the chat. So we have an answer of B. Turns out that's the correct answer, so need me to explain it, or are you
I think I'm good.
okay? So next question. Which pattern will you get if you join the centers of each of the neighboring hexagons? So we'll give you 3 minutes to think about this, and if you have the answer, please type in the chat.
I answer.
So D. Uh, huh. That's not the correct answer. The answer is C. We can figure this out by trying to actually connect the things. So we can, my drawing sucks a lot. So let's just try to connect all the centers right now. And we can kind of see that it's C. My drawing skills kind of suck, but yeah. Because natural numbers are to be painted. So 1 is red, 2 is green, 4 is red, 5 is blue, uh, so on. So basically it goes red, blue, and then green. Which colors can the sum of a red and blue number have? I'll give you 3 minutes to think about this. If you have the answer, please type in chat.
I answer.
Cool. A. That's correct. So do you need me to explain it or are you fine?
I think I'm fine.
Cool. Next problem. When Lisa the cat is lazy and sits around the whole day, she drinks 60 milliliters of milk. When she chases mice, she drinks a third more milk. In the past 2 weeks, she's chased mice on every second day. How much milk has she drunk in the past 2 weeks? I'll give you 3 minutes to think about this, and if you have the answer, please type in the chat. So, uh, think I'll give you the answer since it's been a while. The answer is B. So the way we do this is by looking at the pattern here. So first she drinks 16 milliliters, then she drinks 80, then she drinks 60 again, then 80, and then so on. Pattern is every single time you switch between 60 and 80. However, we can make them into clumps of 2 days. So every 2 days she drinks 140. And since she goes 2 weeks, which is 14 days, multiply 140 times 7 to get our answer, which is B. So next, black and white tiles can be laid on square floors as shown. You can see floors with 4 black and 9 black tiles respectively. In each corner there's a black tile. Each black tile touches only white tile. How many white tiles would there be on a floor that had 25 black tiles? So I'll give you 3 minutes to think about this. If you have an answer, please type in. Since class is pretty much over already, I'll just explain this problem. So basically, you can see that the number of black tiles corresponds to the length of each side of the face. So every time we add a black tile, we add 2 to the amount of 2 to the length of the side. Since 3 black tiles is 5 and 2 black tiles is 3, we can conclude that if we have 25 black tiles, the square root of that is 5. 5 can get you side of 9. We multiply 9 by 9, which is the total area of the square, and we get 81. Then you subtract 25 from 81, because that's the number of black tiles. Then we get our answer of 56. So the answer is D. And so in summary, we learned about patterns, learned about arithmetic sequences, multiplying patterns, or geometric sequences, complex patterns, and sums of arithmetic sequences. See you next week.